Graphs of the secant and cosecant functions. So we have cosecant function. Cosecant function, as we know, is the reciprocal of sine. So this is 1 over sine x. So to draw cosecant function, first we will try to draw sine function and then try to get the reciprocal. So let's get the coordinate system. Roughly 3 units is pi. Pi is 314. 2 pi, and so on, minus pi. And in the middle we have pi over 2, 3/2 pi. And let's draw the dotted sine line, because based on the sine curve we will find the reciprocal 1 over x. So sine curve has a S shape. So sine curve is going right here. Pi is going to -1, and so on, pi. This one is 3 pi. And the same in the negative part. Okay, so that's my sine curve. Now we need to draw cosecant, which is reciprocal 1 over sine. So we're gonna go with the particular values. I have the value 0 for sine. Now cosecant will have 1 over 0. 1 over 0 does not exist. So in that case, my cosecant has an asymptote. At the points where sine is 0, the cosecant function has an asymptote because the function does not exist. So at 0 we have an asymptote. At pi the value is 0, so 1 over 0 does not exist. At 2 pi, 1 over 0 does not exist. 3 pi, and so on. The value of the function is 0, so now I take 1 over 0. That's why I have does not exist. Now, this point has value 1. 1 over 1 over 1 is 1. This point approximately has value of half, 1/2. So we have 1 over 1/2. 1 over 1/2 to divide by a fraction means to multiply by its reciprocal. So this one is 1 times 2 over 1, which is 2. So this value roughly is 1/2. So now it's going to 2. And this value is roughly 1/4. 1 over 1/4, flip it over, that 1/4 gives you 4. So it's growing, growing, growing. And the same here. This value is 1/2, flip it over, it's gonna be 2, and so on. So this part of the graph looks like this. Okay, so the red graph is the first part of cosecant function. And similar situation happens on this one. This point is -1. -1 over -1 is still -1. Now this point has value -1/2. So the same situation we have. Now we are going 1 over -1/2. And that gives me 1 times, flip the over, so we have -2 over 1, which is -2. So this value, where was 1/2, now it's gonna be -2. -1, -2. This one is +1, 2, and so on. Okay, so this part goes to 2, so this part gives me this shape of the graph. And then the same situation happens for this one. Okay, so that's the graph keeps going more like parabola shape. And then with the same situation happen for this one. Okay, so the red graph is y is equal to cosecant x, inverse of the sine. So usually to draw this, to draw cosecant, we use the sine graph, and then you can make the asymptote. Where the sine graph has 0, we make the asymptotes, and down there where was 1, that's gonna be my 1 bumps up and going the opposite way. Now we would like to talk about properties of the cosecant function. Properties of the cosecant function. Okay, so first we have the domain. What's the domain? Domain is the part of the graph where the function is spread on the x-axis. So the function is going, it's like everywhere, except the asymptotes. Asymptotes are at multiples of pi, 0, 1 pi, 2 pi, 3 pi. So the domain is nothing else, it's real numbers minus multiples of pi. Multiples of pi. Or we can write that the domain is all real numbers minus k pi, where k is an integer. Range. What's my range? Range is the window on the y-axis where my function is spreaded. So keeps going, keeps going, keeps going, keeps going. But here in the middle we don't have the graph. This graph is the red graph is, there is a gap right here in this window. So we have from minus infinity up to minus 1, and then there is nothing in the middle from 1 to infinity. So we have from minus infinity to minus 1, and then from 1 to infinity. Let's think, what is the period of this function? What's the period of this function? Period is the part that when you cut it and you keep repeating, you can copy, you get the whole graph. So if you take only this part, the first part, and you copy, you would end up with a graph like this. If we take only the first part and copy, we would end up with a graph like this. If we take only this part, right? If we take only this part and copy. So we certainly need to take those two, up and down, in order to have the graph. Because if I take, cut it out this part and copy, I would have 1 up, 1 down, 1 up, 1 down, and so on. So cosecant function, cosecant is periodic with period of this length. This length is 2 pi. So the period is 2 pi. By the definition of period, that means that cosecant x plus 2 pi is equal to cosecant x. And the function is reflective by the origin, so that's the next property. That's the next property, that the function is odd. Okay, the function is odd. That is, cosecant minus x is equal to minus cosecant x. And the last property is that the vertical asymptotes are at multiples of pi. In a similar way, we will construct secant function. In a similar way, we will construct the secant function. So we know that secant function is 1 over cos. So first we draw dotted line. First we draw the cos function using the dotted line. roughly 3 units is my pi, 2 pi, 3 pi. In the middle between pi and 0 is pi over 2. This would be 1.5, so 3 pi over 2 minus pi over 2. And now let's try to make the graph of cos function. Cos function has a V shape, so starts from 1 and goes to -1 and goes to 0 and goes to 2 pi and then goes to in the middle and then goes to 3 pi to -1 and so on. Oh, a little bit lower, okay? And the same goes right here, so goes positive and then goes to -1 and so on, and then keeps going up. Okay, so this is my cosecant function. The same way as we constructed the cosecant, now we would like to talk about secant graph. So first find where is the asymptotes. Asymptotes would be at the point where this cosine is 0. Cosine is 0 at pi over 2 because the value is 0, so I would have 1 over 0 that does not exist. So at that point my cosecant has an asymptote. At pi over 3 where the cosine, then my secant has an asymptote. Those are asymptotes of the secant function. So in halves we have asymptotes and minus pi over 2. And the same way as before, 1, the value is 1, 1 over 1 is 1, and if I consider this 1/2, 1 over 1/2, as before 1 over 1/2 gives me 1 times flip this fraction, 2 over 1, which is 2. So this value goes up. So the graph goes up. Here we go. And then it goes down. And then it goes up. And the same way goes down. Okay, so the red graph is secant y is equal to secant x. Now we would like to find the domain, range, and other properties of this function. So So domain is the window. Domain is the window on the x-axis. Is the window on the x-axis where my function keeps spreading. So the function goes everywhere except those asymptotes, right? Asymptotes are at half pi. So that would be odd multiples. It cannot be even because even would be 4 over 2 is 2, and that's not. So the domain is all real numbers minus odd multiples of pi over 2, because we have 1 pi over 2, 3 pi over 2, 5 pi over 2, and so on. So in symbolic way it would be r minus k times pi over 2, where k is an odd integer. Range is my window on the y-axis where my function is spreading. So the graph is basically everywhere except this part. There is no graph in this window. There is no graph between those two. So we have from minus infinity up to -1, and then from 1 to infinity. This part where is cosine, there is no secant graph. So the range is minus infinity to minus 1 and 1 to infinity. And secant is a periodic function with period 2 pi, because if we want to take one part, we take this one and check the length. So here's half pi gives me pi, and here's half and half pi, another 2 pi. So the function is periodic with period 2 pi. By the periodic function, that means that secant x plus 2 pi is secant x. And that function, notice, is symmetric by the x-axis, by the y-axis, is symmetric by the y-axis. So that means that the secant function is even, the same as cosine. Secant is 1 over cos, so cosine is even, the function is even. That means x at minus x is equal to secant at minus x is equal to secant x. And vertical asymptotes are at odd multiples of pi over 2. So now we have example. Graph each function, show at least 2 cycles. And we have a y is equal to minus secant x plus 2. So first we will start with the graph y is equal to secant x. And secant x, I know that secant is 1 over cos. So the graph of cos was the V shape. 2 pi, here is pi. So my secant has asymptotes at halves. So my secant graph is pi over 2 minus pi over 2. And here at 1 the graph goes up. And then it's pi, and then it's 3 pi over 2. And then the other graph goes here. At least 2 cycles, so we do need to consider more. Here would be 3 pi, 2 pi. And we have one more bump, and then here would be another bump. That's the secant graph. We will draw it nicely big graph. And then we have minus. Number 2, y is equal to minus secant x. That minus is outside, so I will use the reflection by the x-axis. Reflect by the x-axis. And then number 3, y is equal to minus secant x plus 2. So this 2 is outside. We're gonna move 2 units up. We will move 2 units up. So let's draw the nice graph. That we don't have too much confusion, I'm gonna do the reflection. This part goes down. This part goes down right here. And this part goes up right here. That's the reflection. This part goes down right here. And this part goes up right here. So the red graph is number 2 graph, that's my reflection. So I will start with the reflection and then I will just shift it. Then I will just shift this graph. Okay. So let's draw a nice graph. Pi, 2 pi, and we need more. minus pi. So we know that asymptotes are at half pi, so pi over 2, I'm gonna draw the asymptote. 3 pi over 2 is my another asymptote, and then 3 pi, here's my in the middle another asymptote, and the same in the middle is another asymptote, and then in the middle is another asymptote. Okay, so now I'm gonna start with the red graph, graph number 2. That graph number 2 is already reflected graph, the reflected graph. I'm gonna use it so I don't have too much confusion. So on the x-axis we have the graph going down, and then at 1 the graph goes up on the other part, and then on this one graphs at 1 goes down, and on 1 goes up. They ask me to use at least 2 cycles. This is my 1 cycle, this is my another 2 periods. 2 cycles mean 2 periods. And now I'm gonna shift this graph 2 units up. So asymptote stays as they are. Asymptote doesn't shift. Asymptotes doesn't shift. You can move them up too, but that's a straight vertical line, so we don't see the shift. And now this one, this goes 2 units up. 1, 2, right here. 1, 2, so that's right here. Here we go. And this one goes 2 units up. 1, 2, it's right here. And this one goes 2 units up, so 1, 2. Okay, and this one goes 2 units up, so it's 1 and 2. So that's my final answer. The blue graph is number 3. Y is equal to minus secant x plus 2. Now we have example 2. We would like to draw the graph B. Y is equal to cosecant x plus pi over 2. So first we will start with y is equal to cosecant x, and then number 2, y is equal to cosecant x plus pi over 2, positive, so we are moving pi over 2 to the left. Okay, so cosecant graph, we know that cosecant x is 1 over sine, so roughly speaking my sine has S shape, 2 pi, in the middle is pi. Okay, so cosecant has the asymptotes at whole numbers. So let's draw nice graph. And they ask us to show at least 2 cycles. So we have 1, we have minus 1, and 1, 2, 3 is pi, 2 pi, 3 pi, minus pi. So the asymptotes are at pi for my cosecant graph. And my cosecant graph looks like the one, this one is up, this one is up, so it's up, so it's right here. and this one in the middle is going down, and this one in the middle is at 1 going up. Okay, and this one in the middle is going down. Okay, so now we need to shift everything. Now we need to shift half pi to the left. So first I'm gonna shift the asymptotes. Half pi, so this, if this one was pi, in the middle is pi over 2, and this one was 3 pi over 2, and this would be 5, 2.5, which is 5 halves, and this one is minus pi over 2. Okay, so now we are shifting this graph pi over 2 units to the left. So as asymptote from pi goes pi over 2 right here, and asymptote from 2 pi goes to half pi, and this asymptote from 3 pi goes to half 2. So it's get a little bit confusing. From 0 goes to pi over 2 to the left, and then this graph is shifted right here. So that's nothing else but secant, because secant shifted pi to the left, half pi to the left, is nothing else but secant. So this is moved to the left pi over 2. And this one is moved pi over 2 to the left. Okay. Trying to make it trying to bold it so we can see this nicely. Okay, so the red graph, you can easily clearly see that it's shifted, and this would go shifted here, oh, from 1 right here. No, this part. Okay. So this graph y is equal to cosecant x plus pi over 2.